CLO2.4, compute the coefficient of determination. Okay, since we're talking about correlation and scatter plots, we are going to talk about two more measurements that we'll use a lot. One is called the coefficient of determination. We use the symbol r squared to mean coefficient of determination, and then we will use the symbol 1 minus r squared to talk about the coefficient of non-determination. And before I get too far into what those are, let's have a little bit of a reminder of what r is. In a previous lesson, we learned about r. R is called the correlation coefficient, and it measures the strength and direction of the relationship between the independent and dependent variables. So as an example, if we were talking about study time and grades, and if we found out that R was 0.9, that would mean the relationship between study time and grades is strong and it's positive because R is close to 1. It's strong and positive linear relationship. And that means if we were to make a scatter plot, the dots are going up from left to right and they are close to the line. That's just a review of what the letter R means. And just as a reminder, R can only take on values between -1 and 1. If R is close to -1 or 1, those are very strong relationships. And if R is close to 0, they are weak relationships or no relationship at all. All right, I say that as a review because we will use R to find the coefficient of determination, which is R squared. So R squared, you just take the R that you got from your calculator, you take the correlation coefficient, and you square it. Now, if you square something, you are only ever going to get positive values. And since the biggest R can be is 1 or -1, when you square it, 1 squared and -1 squared is just 1, and we're not going to have any negative values because we're squaring. So R squared is always going to be between 0 and 1. Okay, and R squared is called the coefficient of determination, which is another measurement which tells us something else. So let's go back to our example of grades and study time. R squared in this example would be 0.9 squared, which would be 0.81, which fits what we predicted. It would always be a number between 0 and 1. And what does it mean? That's the real question. Well, what this really means is that 0.81, that's 81% of the variation in Y. So of the variation in grades, for my example, but I'll just say variation in Y, can be explained by X. In this example, can be explained by study time. Okay, that's the coefficient of determination. There's one more measurement, and we call it 1 minus R squared. Which basically you take R squared that you already found and you subtract it from 1. So again, this is going to be a number between 1 and 0, and this is called the coefficient of non-determination. So for our grades and study time example, 1 minus R squared would be 1 minus 0.81. The coefficient of non-determination would be 0.19, but what that would actually mean as an interpretation is that 19% of, for example, in this case, of the grades, of the reason you got the grades you got, cannot be explained by study time. So there's going to be other factors cannot be explained by study time. All right, well, we'll do some more examples to make sense of this, but just remember as a review, R is called the correlation coefficient. That tells you the strength and the direction of the scatter plot and of the data. Are the data points close to a line, and are they going up or are they going down? Then we'll use that number, we'll square it, and we'll get the coefficient of determination, and that gives you the percentage of the variation of y that can be explained by x. Then you can take that number, subtract it from 1, and you'll get the coefficient of non-determination, which is the percent of variation of y that cannot be explained by x. It's explained by something else. Okay, we'll do some examples. All right, we are given an example where we have a relationship between study time and an exam grades. So it says find the coefficient of determination. So they're asking us to find r squared. Problem is we must first find r before we can do anything. And the way you find r is you'll enter the data. So you'll do mode 3-2. You should have x and y. If you have frequency, it's not really necessary in this case. It will just automatically fill in with ones, but you'll put the x and the y in. After you put that x and y in, you'll press AC, and then you're going to press Shift 153 in order to get r. And we will get r equals 0.775. And just as a reminder, this tells us two things. It tells us strength and directions. So it's moderate or strong, not very strong, but moderate to strong, positive linear relationship because r is positive. And it is closer to 1 than not. And so really, if we were looking at the data, it would be positive and it would be moderately close to a line going up. Well, now we can go ahead and answer the question, what's the coefficient of determination? So you will put 0.775 squared. It's actually better if you have the answer already in your calculator just to press answer squared. That way we're not losing anything due to rounding. So I'll do answer squared, and I will get that r squared is 0.601. Okay? So that's the value of the coefficient of determination. But if we're going to comment on it, we should write a whole sentence, and that is, we turn it into a percentage, and we say 60.1% of the variation in the exam mark. So we can just shorten it and say, of the exam mark is explained by, I guess this is the study time. Now, when they ask for the coefficient of non-determination, that is 1 minus r squared. So we will do 1 minus 0.601. We'll get that the coefficient of non-determination, 1 minus r squared, is 0.399. All right, and if we wanted to comment on it, we could write the sentence that 39.9% of the exam mark of the y cannot be explained by the study time alone. There must be other things that also affected the exam mark. And that makes sense because study time is a big factor in how you score on exams, but it's not the only factor. Attendance is also a factor. Maybe your intelligence is a factor. Maybe how much homework you did. There are other things in addition to study time that also will affect your exam mark. Okay, here is another example. We measured waiting time at a store and how it affected sales. So again, like usual, what we're going to do is you do mode 3-2. You should see a table that has X, Y, and frequency. You enter your data into the table, and then you press AC to save it. And we have to start off by finding the correlation coefficient. So you press Shift 153, and you'll get a correlation coefficient R. In this case, we'll get an R of minus 0.96. And let's stop for a minute and think about what that means. That's the correlation coefficient. It means it's a very strong, because it's very close to -1. It's a very strong negative linear relationship, which means if we were making a scatter plot, the dots are going down and they are very close to the line. All right, well, now that we have that information, we can use it to find the coefficient of determination, r squared. So it's just -0.96 squared. Even better is if on your calculator you just press the answer squared button. That way we don't lose anything to rounding. So I'm going to press answer squared, and I will get that r squared is 0.922. So that's the value of the coefficient of determination. It's always a number between 0 and 1. If you wanted to comment on it, we would write this sentence. 92.2% of the variation or of the sales can be explained by the waiting time. So that shows that the waiting time has a very big effect on the sales. Okay, and now to find the coefficient of non-determination, that's 1 minus r squared. So it's 1 minus 0.922. So we will get that the coefficient of non-determination is 0.078. That's the coefficient of non-determination. If we wanted to comment on it, we want to turn this into a sentence. We would say 7.8% of the sales is not explained by the waiting time. It means there's some other factors that will affect the sales beside just the waiting time. Maybe the price, maybe the skill of the salesperson, other things in addition to the waiting time. But we can see in this particular set of data that the waiting time has a very, very big effect on the sales. Okay, one more example. This one is slightly different because instead of giving us a table of numbers, they gave us the scatter plot and the equation of the line of best fit, and they actually gave us in the question r squared. So find the coefficient of determination r squared. It's given. We can see right here r squared is 0.9494. It's given. Okay, if we want to comment, that's where we turn this decimal number between 0 and 1, we'll turn it into a percentage and say 94.94% of the hours, no, sorry, that's a mistake, of the Y value. So of the production of the Y value is explained by hours, the X value. So then the coefficient of non-determination, 1 minus r squared, is just 1 minus 0.9494. So we get that the coefficient of non-determination, 1 minus r squared, is 0.0506. It did not ask us to comment, but I bet the next question is that. What percent of production cannot be explained? Well, that is from the coefficient of non-determination, so 5.06% cannot be explained. Anytime they're asking for what cannot be explained, that's the coefficient of non-determination. So let's review all of the ideas that we've learned in CLO2.4. All right, here is a table of data, and you should know by now the first thing you need to do when you see a table of data is you need to enter that into your calculator. We do that by pressing mode 3.2. We will enter the data into the X and the Y column. You do not need the frequency column for this learning outcome, and then you will press AC. Then it asks, what's the value of the correlation coefficient? So they're asking for R. And after I type all of that in my calculator, I get R equals 0.99. That's the value of the correlation coefficient. And what that means is it is a very strong positive linear relationship between the variables. That means if we were to draw the scatter plot, the dots are very close to a straight line and they are going up from left to right. So in fact, I already answered part B. Describe the relationship. So this would be part B. There is a very strong linear relationship, very strong and positive linear relationship between the variables. If we wanted to find the coefficient of determination, that is just r squared. Better to just press answer squared on your calculator so you don't lose anything to rounding. So I'll press answer squared, and I get, in this case, that r squared is 0.98. It didn't ask us, but what that really means is that 98% of the height, I guess, of trees can be explained by the age of the tree. Okay, now part D, the coefficient of non-determination, they're asking for 1 minus r squared, so that's 1 minus 0.98, which is going to be 1 minus r squared. The coefficient of non-determination is 0.02. And again, it didn't ask us, but if we wanted to comment on this, what does this mean? We would say that that means 2% of the height of the trees cannot be explained by age. So that means a very small percentage of the height of the tree is due to something else beside age, cannot be explained by age. Maybe it has to do with the amount of water or the amount of sunlight. That would be 2%, but 98% of the reason the tree is the height that it is because of how old the tree is. Okay, here is another example where they did not give us a table of data. Instead, they directly gave us the scatter plot, and they gave us some information about the equation of the line of best fit and r squared. Now, they're asking for, in part A, the correlation coefficient. They're asking for r. So if we have r squared given to us, how can we go backwards and find r? Well, we have to find the square root of r squared, but not so fast. When you take a square root, you can have the plus version or the minus version of the square root. So we have to actually look at the scatter plot and see that this is a negative linear relationship. The dots are going down. So what that really means in this case is that r should be a negative number. So we're going to take the negative square root of r squared if we want to find r. So r in this case is going to be the negative square root of 0.8941. So let's see what that is. It will round to be negative 0.95, which, as you remember, for correlation coefficient, that tells us the strength and direction. That's a very strong and negative linear relationship, meaning the dots are going down and they're close to the line, and we see that is true in the scatter plot. So now we'll answer part B, which says coefficient of determination. Well, remember, that was just given to us, 0.8941. The only issue here is, before I circle it, they asked us to round to 2 decimal places. So again, when you round to 2 decimal places, it's either going to be 0.89 or 0.90, but since this 4 is less than 5, we'll round it and say 0.89. And if they asked us to comment on it, which they did not, but it means that 89% of the variation of y can be explained by x. Let's answer the last part. The last part is asking about the coefficient of non-determination. Well, that's just 1 minus r squared. So that's just 1 minus 0.89, which is going to be the coefficient of non-determination is 0.11, which means 11% of the variation of y cannot be explained by x. So here is just one final summary of each of these measurements and terms before we finish up. R, which we actually learned in previous lessons, R is called the correlation coefficient, and it is a number that is always between 1 and -1, and it tells you is the relationship strong or weak, so it tells you the strength, and is the scatter plot full of dots going up or down, so it tells you the strength and direction of the relationship between x and y. Moving on, we have r squared. That's called the coefficient of determination. And because you're squaring r squared, the coefficient of determination, is always going to be between 1 and 0. It's always a positive number. And it tells you the percent of variation of y that can be explained by x. Okay, and lastly, we have 1 minus r squared. That's called the coefficient of non-determination. That is also always going to be a number between 1 and 0. And that tells you the percent of variation of y that is not explained by x. Okay, that's a summary of lesson 2.4.